Hey everyone and welcome. Today we are diving straight into Chapter 5 of the official Python tutorial. We're going to talk about something absolutely fundamental to all programming, how we organize information. And, we'll start with a simple question. Seriously, have you ever thought about that? Your social media feed, your to-do list, even a game. Every single program out there has to manage huge collections of data, user profiles, posts, high scores, you name it. And that's the core problem we're going to solve today. And this is exactly where Python just shines. I want you to picture its data structures like a programmer's toolbox, right? I mean, you wouldn't use a hammer to turn a screw. It's the same idea. Each data structure is a specialized tool, perfectly designed for a very specific job. So let's go ahead and grab our first tool out of the box. This is the list. You can think of it as a super flexible, all-purpose container. Honestly, it's probably the one you're going to reach for most of the time. Okay, now you really want to pay attention to two words here, mutable and ordered. Order just means that items stay in the exact spot you put them, but mutable, that's the magic word. It means the list is changeable. You can add things, remove things, and shuffle everything around long after you first create it. It's totally dynamic. And how do you make all those changes? Well, with methods. The Python docs list a whole bunch, but these are some of the greatest hits. You can append to tack something onto the end, or pop to take the last item off, which is perfect for using a list like a stack. You can sort it, reverse it, or even insert an item exactly where you want it to go. This flexibility is what makes lists so incredibly powerful. Oh, and check this out, a really powerful shortcut called list comprehensions. Instead of writing a big multi-line loop just to build a list, you can do it all in one clean, super readable line. This little snippet here, it creates a list of the first 10 square numbers, just like that. This kind of concise, elegant code is exactly what people mean when they say something is Pythonic. Okay, but what if you have a list of things that you absolutely do not want to be changed? Well, that brings us to our next tool, the tuple. Right away, you can see the difference in syntax. Square brackets for lists, parentheses for tuples. But the really critical difference, the one that matters most, is on that last line, mutability. So yeah, this is our second tool, the tuple. If a list is like a flexible cardboard box, a tuple is more like a sealed, tamper-proof package. Once you put something inside and seal it up, it is set in stone. The key word here is immutable, which just means unchangeable. Now, like a list, it's ordered, so your items are always going to stay in the same place. But the second that tuple is created, it's locked down. You can't add, you can't remove, you can't change a single thing. And Python takes this rule very, very seriously. If you create a tuple and then you try to go back and change one of the elements, Python won't just tell you no, it'll stop everything and throw a type error. It's basically a built-in safeguard to protect your data from being changed by accident. But just because they're immutable doesn't mean they're not useful. Actually, one of their coolest features is something called sequence unpacking. It lets you assign all the items from a tuple to different variables, all in one shot. It's just a really clean, really efficient way to hand out values. Okay, on to tool number 3 in our toolbox. Let's imagine you have a collection where you really don't care about the order of things, but you absolutely, positively cannot have any duplicates. For that job, you reach for the set. So, to really see the magic of sets, let's take a simple word like abracadabra. Just notice how it's completely full of repeated letters, right? We've got A's all over the place, a couple B's, a couple R's. Now watch this. If we pass that string to the set function, poof, just like that, all the duplicates are gone. We're left with just the unique letters. Sets automatically enforce uniqueness, which is so incredibly useful when you need to, say, find all the unique visitors to a website or something like that. But wait, there's more. Because sets are based on a real mathematical concept, they support all these powerful operations right out of the box. You can find the difference between two sets, or their union, or their intersection. It's almost like having a Venn diagram calculator built right into the language. It's awesome. All right, time for our final and maybe most powerful tool. Let's look at the dictionary. If the other data structures are like boxes, you can think of the dictionary as a file cabinet where every single piece of information has its own unique label. The core idea here is really simple. Every entry in a dictionary has two parts, a key, which is the unique label, and a value, which is the actual data you want to store. So in this case, the names are the keys and the numbers are the values. Simple as that.
And when you write it in Python, it looks just as intuitive. We use these curly braces, and for each pair, you just have the key, a colon, and then the value. This creates a really clear, direct mapping between a label and its data.
Now, this is a complete game changer compared to lists. You don't get your data by its numerical position, like item number 3. No, you use its unique key. So if you want Jack's number, you literally ask for tell Jack's. This makes looking up information incredibly fast and logical, which is perfect for things like user profiles or storing settings. Okay, so we have filled our toolbox with 4 amazing, powerful tools. But, the real sign of a great programmer is knowing exactly which tool to use for which job. So, how do you choose? This table right here brings it all together. So, when should you use each one? Well, if you need an ordered collection that you're going to change a lot, you grab a list. If you have data that must be protected and never ever change, you seal it up in a tuple. If you need to guarantee that every item is unique, or you need to do those math-style comparisons, that is a job for a set. And finally, for any kind of labeled information where you need super fast lookups, the dictionary is your best friend. That is the main takeaway here. Always choose the tool that fits the purpose of your data. So there you have it, the core data structures in Python. These are the fundamental building blocks for pretty much any program you could ever imagine. Now you've got the tools, so the only question left is, what are you going to build?